Right, I'm getting ready to do the first proper tests of the Vidor valve radio that I sort of inadvertently did a little bit the other night, as you saw in the other videos, which was checking the rectifier diode. So what I'm going to do is I'm going to just go stage by stage, as I really wanted to do it the other night, except there was I understand why mistake I made. I wasn't thinking properly. Because obviously these two capacitors here from the mains feed from the rectifier diode. Here, I'll just scroll that up. This is the rectifier diode, and you see one side of it goes off to feed the B plus here through this choke. And capacitors C30 and C31 are the main smoothing capacitors, which on this diagram were 16 and 24 microfarad. But the actual ones in the unit, the large can, were 8 and 16. But I only had... the only ones that arrived were the 222 microfarad ones. So both of them are the same. Anyway, I've got 222s here. The only one that I'm missing now, which I'm still waiting in the post because of the postal strikes, is this one here, which is a 4 microfarad, 450 volt, which is this one, which is the one that came out. So that's the Duff one. So you can see the size difference. That's the end there that was corroded, as you can see, which has come off here, and then the other side goes to earth as well. What I've also done, which I've been thinking about for a while, and then I kind of had a bit of a brainwave just to get around it, because you can't get terminal tie strips in this country very easily at all. It seems Americans use them a lot, but we don't seem to have them. So I had just normal mains connectors, and what I did was use an existing hole in the chassis. I bought some 2mm, about 30mm, 25mm screws, nuts and washers, and I thought, right, I'll fix them. And then I had little 3mm terminal earth ties, earth connections. So I thought I'd utilize an actual mains connector, but not actually screw to it, because, ideally you want soldered connections for vibration, obviously, because it's just going to, there's going to be sound when it's running. So I rigged that up instead, which I thought was a pretty good way of doing stuff. So it's all very secure. These are now the 400 volt 22 microfarads, which is C30 and C31, which I've just tied in, but they're really solid, because I put in a mains bus here, but it doesn't really matter. The attempt of putting in a rather, not a mains bus, an earth bus, an earth ground with just using solid cable from mains cable, because there's earths all over the place here. They obviously didn't, I think back then they didn't know the notion of a star ground to prevent hum. But with the old stuff anyway, like on the old valve amps, if you have a choke in, they're absolutely amazing at reducing mains buzz anyway, so they're really quiet. So I'm hoping that after hearing the buzz the other night, obviously without even the two mains caps, I mean, you didn't hear it on the video. It was quite loud in the room because it was also vibrating against the speaker on the table. But in actual fact, it wasn't really, it was loud to me, but you didn't hear it on the phone. And that was without the two mains filter caps in. And what I'd actually done, because these were disconnected, I just wasn't thinking, and I'd still had the connection through to here, because they were joined, they were still soldered together. And because I'd taken the cap out, I was just assuming, I hadn't checked properly. My fault. That was my first big mistake getting back into valve amps, was not checking properly before I did any work. So at least, I know what I did wrong there. I mean, it was not dangerous or anything, but it was just unexpected that still having that B plus connection, which has kind of helped me because at least I know the rest of the circuit can now handle, in principle, assuming nothing else goes, because I've still got all the old caps, because I'm writing a post on this, which I will put online. It's still got old waxy caps in there, which you want to get rid of, but at least I know this circuit can actually, in principle, handle full mains voltage. But these set of tests I'm going to do now, I want to do properly. So I'm going to use my dim bulb tester here, which I've got a 25 watt light bulb in, to really minimize the current. And I'm going to effectively do that in stages, because if you think about it, if you use a dim bulb tester and just step up through the bulbs, it's a bit like having a stepped variac, really, because you just, if you do the calculations for power, this starts off at something like only barely 200 milliamps max. No, 20 milliamps, I think it is. I think it's only 0.16 volts as amps rather. But anyway, I've got a 25 watt bulb here. I've got a 40 volt. I haven't got a 60. I've got a 100, and then I've got a 150. So what I'll probably do, just for the sake of it, I'll probably just step through the bulbs that I have one at a time and slowly bring the power up. And I'm also going to just do it one valve at a time. And that way, if there's a problem, then I'll know which valve has caused the problem, assuming that the rest of the circuit holds up, and just bring it up in those sort of 4 or 5 step stages. With the only thing that's missing is this decoupling capacitor on the B plus, which is the one here, which of course I didn't have the other night either, without these either, the 2 filter caps. So that's all that's missing. It's not critical. It's not biasing any of the valves. It's only going to be an extra filter for mains, really, as far as I can see, because it's this is the original one. That's actually C25 here, which is the 4 microfarad 450 volt one. I've got a 3.3 coming, but I said it's not going to be here till after Christmas now, and because of the post strikes that we've got here in the UK. So I'm going to go ahead and put the rectifier in, and then fire it up in stages, and then also time it. I'll have the meter on the mains connections, mains in to, well, and there's not really much point. We know it's going to read 240. So I'll have the 2 meters here on the B plus, and I'll probably choose somewhere else for the second one. And I'll also, when I switch it off, I'll do what I used to do, which is I can hear the clock ticking. I've got a few clocks in here, and I can hear the second hand, and then I write down the discharge time every 5 seconds, so I know how long this unit takes to discharge fully. And then obviously make sure I always make sure that I've discharged. It's the only way, in my view. You see a lot of different stuff, people using Stinger leads and stuff like that, which I don't personally agree with, because I like to know that a DC valve unit, is actually dropped, even if it takes longer. I've got plenty of time, not in any rush. I like to see when the DC voltage on a power rail has dropped below a safe sort of 80, 90 volts. And of course, it's exponential. A lot of these ones, if they're working fine, they will discharge from the 100 volts, like in the first 5 seconds. So within 10 seconds, they usually get down to ground, depending on the unit, obviously. Whether it's a guitar valve amp or whatever, but this should only be around 330 volts. But with these smoothing caps in, at least I'll know what the line voltage is with just the rectifier valve in, and then it should drop as I put each of the other 4 valves in, and see how we go, and slowly just bring them up in stages using the dim bulb tester with higher wattage bulbs each time that will allow more current through to the unit each time, and just see what happens. I'll do another video in a minute when it's fired up, and go from there. Right, I decided it'd be a good idea going through the dim bulb tester to check the AC voltage that's coming in across the mains power line, which is, I don't know if you can see that, that's 150 volts AC, and the DC rail is at 179 volts, which is I'm reading here at the top of capacitor C30 there. So I'm reading across here with the mains AC meter at 150 volts. It was quite bright, so it did the usual, what it should do. You can't see it probably, the lights looks very bright with the camera, but it's actually quite dim to me, and I can see the filament even inside this this frosted type bulb. So it was bright, and then she slowly faded out, and after 10-15 seconds the voltage started to rise on everything. So what I'm going to do now is, I was thinking about putting the valves in one at a time, but I think what I might do is just put them all in, and then go through the higher value bulbs each time. So this is going to be the lowest power applied to the unit. As you can see, it's got just over half of actual mains voltage, which is 240 volts here in the UK. So it's running at 150 volts AC with the filaments lit on the rectifier, and we've got the panel lights one of them anyway, because the rest are blown. Running the AC heater circuit, and obviously the heater filament on the rectifier heater circuit, the 4-volt 2-amp circuit is obviously working. So I think I'll put, I don't know, because I don't know the state of the other valves, except that the heaters were tested. I've tested them with a meter, and they're all, so probably I think what I'll do is I'll put them all in and fire up the whole thing, and then just see what happens. Otherwise, it would just take too long. So I'll put them all in then, and I'll do the same test again at half voltage and see where we are. Right, I just fired up the amp with all the valves in. That's with the, it's only reaching 115 volts AC now under that load. And it's coming on for probably nearly a minute. And there's still no DC. The voltage is only just starting to climb now on 4 volts. Gone up to 5 on the DC rail as these valves come into emission, which is taking quite a long time. This is a minute on half power. I don't know whether that's normal or whether some of the valves aren't working or whether they're drawing too much current. There's no smoke. So there's definitely a voltage load. So we had 150 volts before on the AC line. Now with all the valves in, there's four valves in here, plus the rectifier, plus the magic eye on this valve amp. So we're slowly climbing to 18 volts now. But that seems a bit slow to me, but then it is only on less than, well, just over half power. So 240 volt would be 120 would be half, so we're 115, so we're nearly half power. There we go. She's is it starting now? It's just very slow. It's coming into emission with these valves, which is good. I don't mind slow and calm, but only 20 volts on the positive rail. I'd have thought it would have been a bit more than that. But there's no smoke or anything, so that's looking good. At least if there is a fault with any of the valves, it'll be that they failed with no heaters and they're not conducting, which is why we're. Then I still expect to see a higher mains voltage. But what I'll do now is I'll go up to a 40-watt bulb. That seems to have stabilized out at 20 volts only on the DC rail. So whether that indicates a problem or not, I don't know at this stage. So let's switch off and put a 40-watt bulb in and see what she does. You can see I've got an isolated unit here to keep me away from having to turn off the actual switch here. So I'm just very, very cautious with valve amps, and I haven't done anything with them. I haven't worked on a valve amp since 2015, so it's about seven years ago. So obviously I'm just being very careful. Can't be too careful with valve amps, that's for sure. Right, so now I've got a little clear 40-watt bulb in. So let's see what happens. It wasn't initial bright flash. It didn't really dim down much. That probably looks very bright to you, but it's just a filament lit to me. It's sort of a yellow-white filament, but not bright. But now we're showing 160 volts across the AC line. So I'm measuring from where the fuse connection is across to the chassis ground. I'm not measuring across the neutral line because it's got shrink down on it. So the bulb is enough to actually light the internals of the chassis, which is reasonably dark to me. So the camera's obviously a lot more sensitive than my eyes. So again, I can't see filaments on this valve lit. The others are obviously metal case, so you can't see them anyway. And also on the triode hexode, I can't see anything. So I don't know what the state of these valves is. They may not. I don't know which ones are working or whether they or which ones aren't or what at the moment. So we'll see. But I do have a couple of spares for a couple of them, but I'd have to look. But we're looking at 157. She's stabilized out at 67 volts DC. Which again, that's very low. So I think it's time to jump to I haven't got a 60 watt bulb, so I'm going to go straight to the 100 watt, which is the next one up that I have, and see where we are with that. The discharge time on the last round, by the way, was really quick. It just went down to nothing within 5 seconds. So extremely fast discharge rate for the resistor values that are in this particular valve amp. So pretty safe amp from that perspective. As soon as you shut the power off, within 5 seconds, it's down to zero-ish. It's 3 volts or something. It was just very, very quick. Right, let's try the next bulb. I hit the button there by accident, so we're recording. So I just put the 100 watt bulb in. So let's see what happens. Oh, it's not even enough to light the bulb up there. It's a very low current unit. Instead, it's gone to 212 volts now. So we're nearly at full power this unit for mains, and already the DC rail is at 179 volts at 208 volts AC, which is why that bulb. So the bulbs. You can see on the camera. I can see the filament lit, but not. It's very difficult to see it with. Just I can see it with my eyes, but the bulbs that little bit brighter on the camera, the filament. Right, so it looks like that's stabled out at 179 volts DC on the rail at 208 volts. Now we can see a bit of filament light there on the hexode, which is the mixer. Can't see any filament on the GT. I can't remember what it is. It's a 6K7G valve, that one. And not really possible to see from here with the magic eyes lit. Don't know if that's a bit of green there, possibly. Does that glare off the screen? Don't know. Right, let's go up to 150 volt bulb before letting it go to full mains, because we're nearly there anyway. So I'll put 150 watt valve. So it's gone up to 177 volts DC there, stabilized out. Right, there's a nice big 150 volt clear. These are getting like duck's teeth now. I had to buy that one online in a pack of 4. It cost me 10 quid for the 150 watt one. So let's fire it up and see what she says. Right. No current at all through the 150. It's all gone across the radio now. She's at 240 volts, which is line level UK. So nothing's being dropped across the bulb at all. And already you can see the DC power rail has gone to 204 volts DC. See the filament lit there still. I can just see, it's not reflection, I can just see, yeah, we got filament heater lit on the 6G, what is it? I can't remember. 6K7G valve. should be valve 3, which I can't remember what that one does. And the other two are the sealed units. One's the 6v6. This one here is the audio output that feeds the speaker and the output transformer, which you can see at the back there. There's no hum this time at all. It's completely silent. There's not even any mains hum. The speaker on full. And obviously, because this unit doesn't have its own aerial, it's not going to be picking anything up. So it's not going to really matter whether I play with the tuning dial or not. Right, I'm going to take this bulb out and put her on the mains. So it's nearly there anyway. It's at 230 volts, and it's only got 206 volts DC. So whether there's some really high, has bad solder joints in there that's causing a lot of resistance in the circuit, I don't know at this stage, but it should be closer to 300 volts DC, not 200. So there's definitely an issue with the unit. But anyway, let's put her on the mains and see what happens. Right, it's into the mains now. Again, we've got high mains here in the UK now. We're 245 volts, not 240. Although this meter's really cheap. This was actually only a couple of quid in the animal hospital where I buy loads of stuff actually up there. Not electrical stuff. It doesn't. UK's crap. It's not like the States or Canada where you get really good quality gear. We just get a load of shit over here left. So we're up to 220 volts. So really, we're a good 100 volts DC shy than we should be on this unit. So maybe, I don't know. I'd have to look at the circuit diagram and have a think about it at this stage. But I'm not sure. The only thing that comes immediately to mind is that there's so many dry joints on the unit, creating extra resistance across the whole circuit, that she's low on B+. But just, I don't know if you noticed in the videos, but there's the 240, the 22 microfarad 400 volt caps, which are cheap shit. They got ESRs of about 2.5 ohms. So these are probably cheap Chinese rubbish anyway. I said, but nothing's cheap now. I mean, these two, I think they're about £4 each for 400 volt 22 microfarad capacitors in this country. But you can see the size difference against the ones that came out of it were the same size as the silver one that I videoed earlier. So you can see the difference in size. It's created a lot of space inside the actual unit compared to what there was, which is good. So anyway, so at this stage, I still don't know what I'll do with it. I may actually just go ahead as a project and actually recap the whole lot over time. So far, so good, and it's certainly a clean unit. And she seems to want to live, so there's not even any crackles out of the unit. Let's see. I said all the bowls were out. It was on medium wave. Let's see if there's any other stations. So there's not even a sausage of sound. But then there won't be because I haven't got an aerial. So that's what I'm going to do tomorrow. Or later, is put a loop aerial in. Just wrap a few coils of wire around and plug them into the aerial socket here at the back. And then failing that, I'll go and get some 10 meters of 50 ohm coax and actually run the cable to the back from the wall socket, the aerial wall socket that's in this property, just to give it something to try, and maybe there's a signal there for it to tune in. But certainly those mains caps, compared to the other night when I fired it up without them in, and of course you hear the mains buzz. So I know that the audio output is fine because it was buzzing the other night without those main caps in. But now they're in conjunction with the choke. There's nothing coming out of the speaker at all. So, very, very quiet unit, even though it's not, obviously at full power, or certainly the DC rail's not up to full power, even at full mains voltage. So far I'm really pleased. It's just a question now of feeding it a signal and see where we are with that. That's all I can do, and go from there.